Okay, so we're going to start looking at the horizontal stretch. So it's the unruly child. So even though we're saying stretch, remember we could be compressing. So let's look at what I'm talking about. So we have here our red absolute value. I would like now to have a blue translation. So when we're adding or subtracting, if you remember from geometry, it's called a translation. A transformation means I've done anything. I could slide it left, right, up, down. I could multiply it. I could divide it. I could flip it. We're transforming it. So a translation, x minus 3. Okay, if we remember, we take every x value and we add 3 onto it. So basically, our new baby blue is going to look like that. If I come over here and I start to create a chart, so let's see, negative 2, when I put it into function f, said take the absolute value of it. All right, so negative 2 turns into 2, negative 1 turns into 1, 0, 1, 2, 3, 4. All function f told me to do was take the absolute value of every x value. Okay, h told me to subtract 3 from x first, then take the absolute value. Okay, so if I put in negative 2 minus 3 is negative 5, absolute value is 5. Negative 1 minus 3 is negative 4, absolute value is 4. This would be 3, this would be 2. 2 minus 3 is negative 1 is 1. And then 3 minus 3 is 0, and 4 minus 3 is 1. Now I'm going to come back to that chart in a minute, but let's just keep going here. All right, green. Now wait a second, it's telling me to double x, then take the absolute value of it. So let's kind of come over here and do that. Double negative 2, I get 4. Absolute value is 4. Double negative 1, negative 2, absolute value is 2. Double 0, absolute value of 0 is 0. Double 1 is 2, absolute value. Double 2 is 4, absolute value. Double 3 is 6, absolute value. Double 4 is 8, absolute value. Okay, so let's graph these points. When I put a negative 2 in, my green came out a 4. When I put a negative 2 in, my green came out a 4. When I put a negative 1 in, my green came out a 2. When I put a 0 in, 0 came out. When I put a 1 in, 2 came out. And we can start to see the mirror image. When I put a 2 in, 4 came out. And there we have it. So let's look at that green for a minute. We doubled. But when we doubled the x, it didn't stretch. I didn't get twice as big. In other words, you would have thought since I was doubling something horizontally that it would look kind of like that, where I'm tugging on both ends, I'm doubling my x's. It actually did the opposite, right? Instead of stretching it along the x-axis, it stretched it along the y-axis. It actually looks like a y stretch. And that makes sense because it's inside parentheses. Mama said double, and baby said, I'm not going to get wider, I'm going to get taller. Let's look at what would happen if I put 1/2 in. So half of negative 2 is negative 1. So when I put a negative 2 in, I get negative 1 absolute value is 1. When I put 0 in, half of 0 is 0. Absolute value of 0 is 0. And now we know we're going to start getting our mirror image. Half of 2 is 1. Absolute value is 1. So this is what baby's going to look like. Let me drag it up from here. That's what baby's going to look like with a half. A half actually got compressed. We actually pushed down on it vertically, which stretched it horizontally. So if we wanted to do a horizontal stretch and pull this thing like a tug of war left to right, we actually multiply by a fraction between 0 and 1. And if we wanted to make this a tug of war, stretching it up and down, we actually multiply by something greater than 1. So I'm just going to come over here for a second, and I'm going to put in these answers. So when I put in -2, half of -2 is 1. Absolute value is 1. -1, half absolute value is a half. 0 is 0. 1 would be a half. 2 would be 1. Half of 3 is 1.5. Half of 4 is 2. So now, here's what we're trying to show you. That when I put a -2 in, for the original one, I got 2. But if I wanted to get that same y value of 2 in my blue function, it said I would have to subtract 3 from my x, which really means I end up adding 3, right? 1, 2, 3. I have to add 3 on to my x value to get that same y value. This is another reason why we do the opposite. Okay, let's find that too over here. Well, in the green one says double the x. But wait, when I had a -2, which resulted in a 2 for the red, it was a 1 that resulted in a 2 for the green. It said multiply by 2, but I actually ended up taking half to get that same y value. I think you can see where I'm going with this. Okay, so here we go. I have this red kind of looking bucket over here. And first thing, I want to just take a sidestep and talk about the domain. The domain for this red goes from -3 to 4. In other words, 10 is not in this domain. There is no y value that is returned when I put 10 into this wacky function. I can only put x values in from -3 to 4. So that being said, let's look at the critical points, which are the big red dots. So when I put a -3 in, out comes the number 4. When I put a -1 in, out comes a -1. And technically I could put all these in here. If I put a 0 in, out comes a -1. If I put a 1 in, out comes a -1. If I put a 2 in, out comes a -1. And if I put in a 4, out comes a 3. So now I want to create a blue function, g of x. G of x says, to create me, blue, g of x, I want you to go to function f and take half of x. Okay, so let's say I want to put the number 10 into function g. So if I put a 10, will there be a y value? Well, to figure that out, what I would have to do is to find the answer when I input 10 into g, is to go to function f and take half of 10. All right, so when I go to function f, half of 10 is 5. So the output to g of 10 is the same as the output of f of 5, but there is no 5 in the red, right? If I went to 5 in the red, there's no y value there. So guess what? I can't put a 10 into function g. All right, so I'm going to put in an 8. I put in an 8 to function g. that means I go to function f, and I take half of 8. Half of 8 is 4. So when I put an 8 into function g, its output is the same output as when I put a 4 into f. There we go. When I put an 8 into function g, the output will be a 3. All right, hopefully you're starting to see our little shortcut as usual. Okay, so I'm going to stick with even numbers because it's easy to take half of even numbers. I'm going to put a 6 into function g. So that means go look at function f. Half of 6 would mean the answer to when I put a 6 into g is the same as when I put a 3 into f. When I come over here, I don't have a 3, but let's go look over here. 1, 2, 3 looks to be a 1. So when I put a 6, the output is a 1. All right. How about when I put a 4 in? When I put a 4 into the g, it's the same as going to function f, taking half of 4, which is 2. So the output for when I put a 4 in for g is same as the output as when I put a 2 in for f, -1. Hey, that's what that line looks like. But as you can see, we're actually stretching it along the horizontal. It's like we have two people right here, and they're having a tug of war with the graph. They're tugging it. They're stretching it horizontally, which, well, if I stretch it horizontally, why am I taking half of something? Wouldn't I be doubling it if I'm stretching it? But no, remember, it's the horizontal kid. We always do the opposite. And we can see now that our shortcut is this. If I doubled 4, it would become 8. So the y values, we're doing the opposite. Instead of taking half, we're doubling the x's, and the y values stay the same. Okay, if I were to double 2, it goes to 4, and my answer is -1. So I'm going to come over here. I'm going to double -3. And double -3 gets me to -6. And so I should have the same output. I should have a 4 as an output. So let's see if that's right. When I put -6 into g, it told me to go back to function f. I'm going to put in x is -6. Half of -6 is -3. So the output for -6 of g is same as the output for -3 of f. -3 of, it is a 4. Okay, so I'm going to go to -6, 4. So that's the quick way to do it. I'm going to come to my x here. I'm going to double -1, make it -2, but then remember the y values stay the same. I'm going to go to 0. I'm going to double 0. That gets me to 0, and the y value stays the same. So now if I'm going to do this, -2 would be 1. 0, sorry, -1. 0 would be negative. So I can see now when I draw this that even though I took half of the x's, my graph did not move inward. It didn't compress horizontally. It stretched horizontally. All right, so our summary. To do a horizontal stretch, that means to take our graph and stretch it horizontally, we're actually multiplying x with a number between 0 and 1. To compress something, to move it in and compress it, we actually multiply by a value greater than 1. This one is often the hardest for kids to learn. But that's why if you just keep that horrible horizontal in mind and just do everything the opposite when we're working with an x value, it can be a really easy time.